Okay, so there are probably several hundred different programming languages in the universe. In the world. Yeah, about now. But they're all extremely different programming languages. They all have their own syntax, they all have their own way of doing things, they all have, some problems that they're going to solve. So, the question is, what is it that actually makes them different? Why does one designer decide to do one thing one way and another one decides to do another thing? Generally what you find is the set of problems that's out to solve is going to decide what kind of language you're going to end up with. So when I started working on policies on the team, one of the things that got me really interested was not just, okay, so here we're going to make this language thing do this language thing do this, but why we do it and how we can do it better. So I'm trying here to tell you a little bit about plastics. Not much. You're not going to see much syntax. You're not going to see much of like the kind of features we're going to add. But you're going to see more of what's behind all features. But more importantly, you making us a little bit of a better understanding of all programming languages. Like, have you ever been working in a language, doesn't matter, any language, and you come to something and you think, why on earth did they do it that way? That's just so stupid. What were they thinking? So, the key is, take a step back and you think, okay, let me try to put their shoes on for a minute and think, what problem were they trying to solve? What were they trying to do with this feature? And then usually you can see, okay, I understand why they did it that way. It's not the decision I would have made, but at least I can understand. So, you've probably heard about code smells, signs when you're reading some of your code. It's not a bug, but it's a good sign that you could have done it better. You could have written it better. Well, I'm going to talk about language smells. These are the kind of things that you look at a language and you realize, you know what? They could have done this better. So I'm going to start off simple. In general, a simple solution is a better solution. Now, part of this is, if it's a simple solution, it's going to be easier to deal with. It's going to be easier to teach, so more people are going to bother learning it. It's especially true of programming languages. It's going to be easier to learn, also good. Trying to get people to actually use it. Easier to remember and use, which is really good for those of us who spend all our time working in the language. I'd rather not have to put my way through 5,000 pages of reference to figure out, how to print something. No. And it's easier to read, which is good for maintainers. Reading code is a big part of maintaining it. And easier to parse, which is good for those of us who are trying to actually implement languages. Compiler implementers. There's a problem with this, and that is, not all problems are simple problems. So not all problems can be solved by simple solutions. Now, the simplest programming language in the world has no keywords, no variables, no operators. It's really, really easy to parse because it has no syntax, right? But it's not very useful because it's like the null language, nothing. So if you are going to solve the kind of complicated problems that we solve with programming languages, there's going to be complexity somewhere, no matter what you do. The tough decision for designers is to figure out where should that complexity go. It brings us to the principle of the waterbed theory of linguistic complexity. Okay? If you take a waterbed, you push it down on one side, right? The water has to go somewhere, so it's just going to bubble up on the other side. Right? Now, the same thing is true of languages, programming languages and human languages. If you take the complexity and you make it really, really simple on one side, the amount of complexity that you need to solve the problem is going to bubble up on the other side. So we'll take a simple example. If you take a programming language and you give it a whole lot of operators, everything is operators. You know, all you need is 3 operators, you can do anything. Well, it's really hard to read. It's like gibberish, you know. On the other hand, if you take a programming language and say operators are bad, you must have no operators, then you end up with these really long, verbose constructs to do the simplest thing. You know, you're just trying to, you know, add, multiply a few numbers and assign them to a variable, but you have to stretch your way out. So the trick is to find the balance. Somewhere in the middle between there is the perfect way of phrasing something. And that's going to change between languages, you know. My way is not your way, my language is not your language. Just find the balance. By the way, feel free to interrupt me with questions. Not that you necessarily have any at this hour, but, you know.
Well, actually, the waterbed theory is interesting. We're saying the conservation of complexity. Isn't it more like the entropy never decreases? You can always increase complexity for no gain.
Yes, you can. You can. What he's saying is you can always increase complexity. It's absolutely true. You can increase complexity for no purpose whatsoever, just for the fun of it. Some languages I have the feeling they do that just for the heck of it. But Microsoft's an idea. Maybe so. I won't name any names. Reuse. Another principle. So, when you're designing a language, generally, if you take a feature and you use the same syntax for another feature, it'll be an advantage. So, if you had a language that used like standard block structure for a while loop, but then used like Ada-style if-then-end-if structure for an if block, it would be incredibly annoying. You would never be able to figure out what the pattern is. You'd always be trying to remember, well, let's see, okay, this is a switch, so now, did that use block structure or did that use... It's horrible. So you try to reuse structures anywhere you can. It makes the language more consistent, easier to remember, easier to use, easier to teach, all those great things. And the set of repeated structures that you use throughout the language is what we tend to call the syntactic conventions. It becomes the syntactic conventions just by the fact of its existence. But on the other side, there's always a flip side to every principle. The human mind is designed to filter out small differences. So wherever possible, it will only focus on the big differences. So I'll take an example from English. If the word cat was actually tog, that was the word for it, you would find people constantly having to correct each other. No, I said that Johnson's got a new tog, not dog, tog. So you try to, in a particular context, increase the distinctions as much as possible to make it easy to see between them. Now, the designer trick is to build in visual clues to the language. Now, we found a few things when we went back at Perl and examined the syntax that were irritating. Like this keyword eval was used for 2 completely different things. One was to catch errors, and the other was actually to take a string and execute it as a piece of code. So you can create a string of code and execute it right there. So we split those out into 2 different keywords now. The same with for and loop. 2 different kinds of looping constructs. We use different names for them now. And sub and method. Before, the keyword sub was used in all objects and non-object-oriented code. And it's just nicer to know that it has a different word when it's really something completely different. It makes it easier to tell where you are and what you're doing. So, with the 2 principles seeming opposite each other, distinction and reuse. Now, you see, you want to reuse syntactic structures anywhere you can, if possible. But on the other hand, if you reuse too much, then you're losing distinction and things start to blur together. So you kind of have to stand there on the dividing line between the two and, again, find a balance. It's like surfing language design. Freedom is a principle that not all languages value. It's one that Perl has always highly valued, but that's partly because of the community, partly because of the people who are designing it. So, programmer freedom has always been a big value in Perl development, and that is, you have freedom to use powerful features any way you choose to do. Now, that also means you have the responsibility to use them well. But what Perl has always done is had customs, not laws. This is what you should do, this is the nice thing to do, this is helpful, but not, this is the only way you can write the structure. Other languages take different routes. But for us, what that means is when we're considering features, we're not going to reject a feature just because someone could use it stupidly. Anybody could use a language feature stupidly. Now, if there's other reasons to reject a feature, yeah, sure. We'll go ahead and say, okay, if it is a terrible feature and people could use it stupidly, yeah. On the other hand, despite the fact that we're willing to put in these evil features, we're not above making evil features hard to use. A good example of this is, let's see, a lot of people wanted the ability to access any variable outside the current subroutine from the calling scope. So we'll say, sure, well, you can do that. We're just going to really give you a really long string to do it, so that, the baby Perl programmers aren't going to do it. The really experienced guys who know what they're doing and are willing to do a little bit of nasty stuff with code. Sure, go ahead. If you burn yourself, it's your own fault. Now, the problem is, if you're going to give programmers that kind of freedom, you have to build a very flexible language. Just like nobody wants a cookbook that reads like a Stephen King novel. Nobody wants a one-liner that requires you to define an entire elaborate class structure and yada, yada, yada. It makes language design a little bit harder. It's really easy to say, well, here, you do it this way. There, done. I don't have to think about it any further, that's it. When you have 10 different ways to do it, you have to think through each one of them and decide what's the best way to do each one. But it's fun. Adaptability. Language change is a natural thing. It's as natural as the hair growing in your head. All languages.
Get personal.
I'm not saying anything about the hair on your head. I didn't know. But now, languages change because the needs of the people who are using it change. We are solving very different problems today than we were solving 20 years ago. So the same kind of language that we used 20, 30 years ago is not the same kind of language that we need today. So they change to stay relevant to the needs that we have. Now, if you have a dead language, it's not going to change. That is, if nobody's using the language, then there's no need for it to change. You don't care. The best way to tell a language is completely dead is if there are no compilers or interpreters that will actually run it anymore. Okay, with Parrot, we're going a really long way to make sure no languages reach that point, but I'll talk about Parrot next week. Now, our design trick is to try to not just say, okay, change is normal, but actually try to make it easier for the language to change over time. So So we're building in a few features like we're going to make it really easy for you to modify how the source code is parsed by doing all the parsing in a Perl 6 grammar, which is sort of the next generation of regular expressions. Regular expressions on, like, steroids. And all you have to do is swap in a different grammar, and your source code will parse differently. Very handy. For some of us who like to play dirty tricks. We're also lowering the distinctions between built-in features and user-defined features. Because you'll find over time that what somebody just kind of created as a little add-on for the fun of it will suddenly become extremely useful that everyone must have. So try to make it natural progression. And just try to make it a little easier for user-defined operators and other things like that to be added in. Prominence is, if you're looking at the world around you, you're not going to see everything sort of in just a blur. Some things stick out more than others. So, our trick is to try to use that to help the programmer. Both to help the programmer use the language, and then also to help the programmer help the people who are going to have to reuse code. Or her code. So, in the original Perl, we had things like the begin blocks, which are all caps, to say, hey, I'm outside the normal flow, I run like before anything else, pay attention. And we have a whole bunch more of those now, next blocks and last blocks and pre-blocks and post blocks and et cetera, et cetera, et cetera. Fun stuff if you want to play with it. And then Perl also had the modifier forms of some of the structures. So you can say if something, do something. Or you can flip it around and you say do something, if something. And what that does is it gives the programmer the freedom to say, well, this is the most important part. I want you to focus on this, so I'm putting it first. So blue is really the important part, and what you do is just on the side. You can flip it around. Of course, that makes it pretty tricky when you're trying to decide how to design the language, right? Because you have to not only figure out, kind of put your mind into the programmer and figure out what kind of things he's going to be doing. What are people who use the language going to be doing? How are they going to need to manipulate things to make it clearer? Yeah.
Why do you have the brackets around the if and then next to it? I mean, it's the only language that I like that. You don't do that in C or
Brackets around the if?
Yeah. Well, after the
You mean the parentheses? They're not required anymore.
Not the curly brackets.
Oh, brackets.
For the line code.
Okay, I know that I'm allowed to do that in the C code, but I never do it.
Okay.
Because when I do it,
Makes it hard to read.
yep,
A lot of automated editors will add that automatically as well.
yeah. And it also is the kind of thing that bites you in the butt when you're maintaining your own code, because you come back and you add another line and you don't think about the fact that you didn't have the closing bracket there at the
You
end.
don't do it on the other one.
There aren't any brackets, because in Perl, when you have the modifier form where it sticks on the end of the statement, you can only have one statement, because it's actually part of the statement. There are no brackets.
You can use the two to consolidate the entire block of code and essentially have one statement.
Yes, you can. You can also just use plain block now. Plain brackets on anything.
That's what go-tos are for, damn it.
Yes! Power go-to, man.
I think we actually got rid of go-tos. I'll have to go back and check the spec.
You know what?
We give you all sorts of other evil things. You don't need go-tos anymore. Anyway, this is kind of an interesting principle based on linguistics. So, in natural language, we tend to stick lengthy bits on the end, right? So you can say, I gave Mary the book, or I gave the book to Mary, but I gave the book about the history of the development of peanut-based products in Indonesia to Mary. It does not sound right. You say, I gave Mary the book about blah, 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 blah. So the reason is that when your brain is trying to parse this long sentence, what you do is you start cutting off the blocks of the sentence, and then you get this really long section that's really just a minor part. It's not something you need to worry about. And then you get back to, like, the object of the sentence. So your brain has to do this sort of detour route and come back. Very hard on memory. Humans have a very limited capacity for that kind of parsing memory. Now, the same thing is true when you're trying to read code, right? So in this section here, you read along the regular expression, right? Da 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 da. And then you get to the end and you say, oh, that's a case-insensitive regular expression. Let me go back and see what it was actually going to do. Da 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 da. And the parser has to do the exact same thing. So it's harder for humans, and it's harder for the computer. So we're just going to flop that around a little bit. And I'll just start at the beginning. We made a few other changes too, but you can ignore those. Dwim. Does anybody know what Dwim is?
Do what I need done.
Yeah. Got it. It shows up a lot on the language list, on the process language list. So, here's the thing about Dwim features, right? You want the language to just do what it wants to do. You don't want to have to think about it. You want to... Now, the problem with this is, of course, that do what I mean is not always do what you mean, or what you mean, or what you mean, but in general, you want to try to make the language so that when someone is coding in it, they go along and it seems natural, right? So defining like pages and pages of rules for how a particular keyword works is never going to have the same power as if people just look at the keyword and they think, oh, of course it does that. I mean, yeah, look, it's given, right? So of course. With Perl 6, we have a few eyes that we're targeting in our Dwim. One is, of course, Perl programmers. We want people who have been programming in Perl for a long time to look at Perl 6 and think, okay, here's a new thing, but yeah, it fits right in. I expect it to act this way. Another group we're targeting, maybe less obviously, is English speakers. But not necessarily, we're targeting native English speakers because that's the majority of our users. But you have to be careful because some features in English are very, very unfriendly to people who are non-native English speakers. So in regular expressions, we have a little modifier that says only grab this numbered one, only grab the first one, the second one, third one. So what we've done is we actually give two different forms of these. We give the natural form, first, second, third, with the funny chaotic endings that English likes to use. And then we also give a generic form that anybody can use. And you don't have to remember, now let's see, when you have the 3, and it takes this ending, and when you have the... You kind of got to go both ways. Borrowing. Now, natural languages do this all the time, right? We go over, we steal a word, camouflage, champagne, tortilla, lasagna. But we don't steal it exactly like it was in the original language.
You mean like faux pas?
Faux pas, yeah, that's me. So, like, the original French was camouflure, and it meant something, I don't know what that meant. It had nothing to do with army ring patterns on, like, cloth. But we stole it from them, we used it, we changed the way it sounds. And the same thing's true of programming languages. So, there are plenty of languages out there who experimented with strange little solutions to various different problems. So you might as well go ahead and take what they've already designed and use it. Now, it's a very respectful thing to say, hey, Smalltalk, you did a great job at developing this OO stuff, so we're going to borrow this and this from you. And it makes a lot more sense to openly say, hey, we're borrowing this from you, than to try to pretend that you invented it. Or, even worse, to refuse to use it because you didn't think of it. And I've seen that before. Naming no names. But, because every language has a different syntax and different structure and a different direction, different set of problems it's solving, then the features that they have are not going to fit into our language just pulled straight. So the same way when you're borrowing a word from French into English, you change it. When we're borrowing features from Smalltalk to Perl, we're going to push them around a little bit and fit. It won't be exactly the same, but equivalent. I think we got a little happy there. One of the things that people have said over and over and over again when we decided to sit down and redesign Perl is, it has to still be Perl. Well, of course it has to be still Perl. But what does that mean?
It's a name, though. You
Yeah.
don't have anything to lose.
Because, okay, now a redesigned language is not going to have exactly the same features as the original language. It's not going to have exactly the same syntax as the original language, because if it did, it would just be the original language. There's no point to redesign it to nothing. But some of the things that we can identify that do make the language what it is. Larry originally intended that Perl would make the easy things easy and the hard things possible, right? It has to be light and flexible, but it also has to have solutions for complex problems. So we're still targeting that same zone. We're just going to make the easy things a little bit easier and the hard things a little bit more possible. It also has to be familiar to Perl 5 programmers. When they jump into this language, it has to feel like Perl. So the basic syntax is pretty much the same. We clean it up a little bit. It's actually nicer. But it still has to be Perly. We're also going to make it mechanically translatable. Now, that really isn't going to mean much to anybody 5 years down the road. But when 6.0 is first released, it makes a big difference. Perl has always stuck with the philosophy of, learn enough now to get your job done, and then learn more as you need it. So learn enough about Perl 6 to, figure out where it's broken and then try to translate it. But you don't have to learn every nuance of every feature to keep the code running. Another consideration. We could have made a quick fix in a couple of months that would just patch a few features and keep it running for a couple of years. But we decided that it would make more sense to plan ahead and plan not to have to make this kind of change again for a really long time.
Perl 5 has existed for?
Perl 5 came out 95, I think. Yeah. It's time. Perl 5 was a little patch. Added objects. And slightly clunkily.
Major.
Okay, major clunkily, I'll give you that. So we're not interested in whatever the latest ooh, this is cool, that is. And we're not interested in adding a few, like, exciting tricks that you can do. We're really only interested in building dependable tools that you will use for a really long time. Okay, you might not use them if you don't like Perl, but that people can use for a really long time. And nobody's pretending that we're going to spend all this time and come out with something that's absolutely perfect, the perfect language that everyone must use. It's just progress. It's just evolution. So, we're trying to make a language that is adaptable, freeing, simple but complex, distinct but consistent. It has to borrow, but purposely. It has to be relevant now and then. It has to be programmer friendly. But most importantly, it has to be even more Perlish than Perl 5 is.
I apologize if I covered this when I stepped out for a cigarette, but there were a couple of cases, and I can't remember now, but where you had taken one reserved word and split it into two separate new reserved words. Is that going to cause any backward compatibility problems if you say move to the compiler?
You mean if someone happens to be using a subroutine named try, and so now
Eval in with both instances.
all it'll mean is that if they call try within the code that they define try in, they'll get their try instead of ours. So they'll just be overloading that. That's everything. Yeah.
So but the short answer is that everything should still work as it does now.
The question is your question whether all Perl 5 code will still work?
That's a fair question to ask, but I guess that's what I'm asking.
No, we will break backwards compatibility in some cases, and that's why we have to provide mechanical translation for those cases. Yeah.
What could you tell us about Mason and PHP's very programming language? Mason is based on Perl. Is still a little bit hard to use. I know all because I created 3 minutes head shell script in Perl, just knock out pretty much what I want or getting the job done. But Mason PHP still seems to be hard to use, a lot harder than PHP was. PHP was flexible. You're talking about being Perl, but computers technology is moving forward. At this point, I don't know, most of the websites are running PHP sessions, they're getting code to level 5, like are getting kind of Java like. What can you tell us about Java?
He wants to compare PHP to Mason, which is a set of modules that do templating for websites. Have you looked at Template Toolkit? Because if you're doing web development in Perl, you're probably going to look at Template Toolkit over Mason. It's a lot more like PHP. I have heard a lot of people saying that Perl is losing the web market, which really isn't all that terrible since it never stopped the web market in the first place. But it is something to be concerned about, I guess. But I don't really mind. I mean, I'm quite a pragmatist when it comes to languages. So I'm happy that PHP is getting some market share. That's cool. They're probably never going to be used on Wall Street. They're a very different language. But for the web stuff, they've got it pegged. So, hey, kudos to them.
What is the market that you see like Perl targeted at?
Perl is the chameleon language. It's used on the web, it's used in shell scripts, it's used for major financial applications, it's used for GUI applications, it's used for... And some of that will become when we move to Parrot, Parrot is the new virtual machine that's going to run Perl 6, and actually it's going to run Perl 5. The Pony project is now porting Perl 5 to run on Parrot. So it will actually have like direct access to SDL libraries within the virtual machine, which will mean that Perl can actually, at this point, Perl kind of runs GUI apps on Linux. It's kind of a kludge. It does it, but it's kludgy. So by moving forward the way we are, we're actually going to give Perl access to more of the market. But I don't think we'll ever dominate in any market. That's not really what Perl's about. Yeah.
How exactly, you admitted that object-oriented programming in Perl was a little clunky. How is that different in Perl 6?
Perl 6 is completely different. But we'll still let you do your little kludges.
Well, I don't want to. I want to know how I can do it right.
The Perl 6 model is much more like what you would expect from Smalltalk. It's got true opaque objects. One of the annoyances of Perl 5 objects is there is absolutely no way to protect your object. So any data, any subroutine in your object can be called from outside. There's no such thing as public and private. So we have that now. We'll also have real attributes in the objects instead of just having a little hash that we kind of pretend is attributes. It's some really cool stuff. We've been having design meetings for like the last year. Every few months we'll meet up, and it's really, really cool stuff. Hopefully there you'll have actually that apocalypse finished in the next 6 months. That would be cool.
Considering that, like the Java virtual machine, one of the biggest complaints is that it's slow. What made the Perl Foundation decide to go that virtual machine?
Because we're doing it completely differently, and it's a whole heck of a lot faster. We're actually using a register-based virtual machine rather than a SAP-based virtual machine, which gives us the advantage of years of research into hardware register-based machines that we've actually been taking advantage of. And we've run tests. There have been some very basic, MOS tests of Parrot, and it's running at close to C speeds, which is pretty shocking for a virtual machine. Yeah, interpreting back to. Another question.
Question on Parrot moving forward, will it support other scripting languages such as Ruby or Python?
Well, the question is, will Parrot support other scripting languages? Yes. We're definitely targeting Ruby and Python, and we hope to run Java bytecode straight. There's been some work done on that. There's currently a very basic forth interpreter. There's a defunge interpreter. There's a brainfuck interpreter. There's a... Yes, something's been doing that research. It does have a new interpreter. Yeah. Well, there's actually a contest on right now with Guido next year. There will be a Python contest. Well, not really. Whoever can manage to run some sort of Python code faster, whether it's Parrot or the Python interpreter, will get to throw a pie in the face of the other language. That's what we say, but somebody had a question back there before I went off on pies.
I'm too drunk and I forgot it.
Yeah.
It has nothing to do with that interpreter that involves the word fuck.
Brainfuck. It's a language.
Now, I know you're talking about Perl, but you brought up brainfuck the language.
Dude, you gotta see it.
Well, I know what ook is, all right? Brainfuck.
Look it up. Just do a Google search on brainfuck. You'll find all kinds of
You know what? I'm sorry, but in all due respect, the Google search on brainfuck is not going to give you that.
Okay, search brainfuck, Parrot. Then you'll get it.
I don't know.
So are you targeting C# then?
There is to talk about Yeah, pretty much.
So you're Unix answer, I suppose. I hate to say that. To compete against Microsoft.
No, not really. I mean, we're not really. I don't see it as competition. I mean, is Microsoft going to care about running Scheme? Really? No. But there is. I mean, you've seen the Mono project, right? Okay. Yeah. Look at the Mono project if you're interested in C# on Windows. I mean, on Linux.
Well, I'm not really interested in C# on Linux. I was just hoping the Perl was going to kick my ass.
No, actually, in my other role as Perl Foundation president, I've actually been negotiating with Microsoft for the last few months over licenses on whether they can run Perl on the CLR, because they want to write their own version, but they want to own the copyright. We have trademark. Sorry, guys. Anyway, yeah.
Feel free to not answer this question, but I'm kind of curious about how this works. Is the Perl development mostly a volunteer effort, or do you guys have funding, or is it grant funded? How is it?
It's primarily volunteer.
Yeah.
Like 99% of it. Through the Perl Foundation, we were able to fund about $70,000 worth of Perl development work, but that is just a scratch on the surface of what people are doing. So. People complain about how slow Perl 6 is going, but when you think about the fact that people are doing it on nights and weekends, it's actually going pretty fast. Yeah.
Maybe Perl developers won the NFL.
None that I know of.
3 at least, Larry Wall. He won it at least 3 times.
Woo! Good for Larry.
Nobody else.
Probably. I have to confess, I have never looked at the statistics for the obfuscated key contest. Who was it?
The important issues here as you bring up. I'm supposed to go back through these issues and topics.
Yeah, sorry. I'm just a boring old language designer. Ready to prove it. Anybody else? Okay. You get a long alcohol break this time.